And hi everyone. So welcome everyone. Today we will talk about vector databases. I think it's time in this AI era to have a dedicated episode about vector databases. And I have here my dear friend, developer advocate at Qdrant, Sabrina. Super talented. Follow her literally everywhere. We'll have some links below. Sabrina, please introduce yourself. So I'm super pumped for this event. There will be also some coding, some demo, but before I want to warm up, you answer a couple of questions, and then we get straight into the action as this series is about. So Sabrina, please introduce yourself.
Thank you so much for having me here. It's been a long time coming. It's about time that you mentioned vector databases, and I'm super excited to be the one to bring this to your audience. Hello, everybody. I see like a lot of people here in the audience that I know. It's amazing to be with you guys and chat. So yeah, I'm Sabrina. I am a developer advocate at Qdrant. I think for 1 year and a half now, it's been a ride. And I'm based in Brazil. I've met Francesco actually in person. I'm one of those people who had that pleasure. And really excited to show you guys here today about how to build a rag. Actually, how to teaching Francesco how to build a rag and show you guys how to do this in the process, which I think is going to be super fun. So yeah, all these questions that you guys are talking about are going to be answered.
Perfect. Super excited. I think I have a Qdrant sticker that you gave him, but it's over there. So if I have some time later during the code compilation, I might have the time to get it so I can show the proof. We don't have the proof of getting the pizza together because we just took a picture. Sabrina, perfect. So I think if you have any specific questions, for example, what is a RAG application, just drop them because now we want to focus on the technical part. So we will not make big assumptions. So I mean, let's have as a audience, let's say a developer who has coded a while in their life, but will not pretend that you know terms like even vector databases, maybe databases. You should have an idea to just to follow along, and then I think we can start. And if there are some terms that you don't understand, just write them and feel free also to give your definition to chat here, and everything will be sorted by the end of this video. Okay, so I see here people are ready. I'm happy, very happy about this. Yes,
Yeah.
so Sabrina, the title of this episode is what is a vector database? Someone already asked this, so I will start from that one. So I would like
Yeah.
you to give a explanation of
Yeah.
what a vector database is, pretending that we are at a party with
Oh,
we are
okay.
chilled. So it's just relaxed. Okay, so
Okay. Okay.
you can hear people in the chat. So let's say that we are, that people are at the party, and of course we're talking about
Yeah.
tech. So how would you explain vector databases in this situation?
Yeah, I guess we can start about explaining even like how regular databases work, right? How we're used to using databases or how we have seen like Excel sheets work before. In the ways that usually we have rows and columns and we have some sort of structure, right? We have, for example, a ID field where we have the ID for a specific, I don't know, name, or we have a description of something, but that description is just, text that I can, bring back if I search for a specific thing in the database, but my database doesn't really understand what's in that text. It doesn't understand the name of the thing that I'm trying to retrieve from it, that I'm trying to query. It just retrieves back to me based on the structure that I've built within my database. So this is a structured database for structured data. Now, the real thing here is that these days we know that most of the data that we create is not structured, is unstructured. Those data can be like audio files or descriptions or like text that we just, write on Twitter, or an article even. Like, how do you put an article in a database? And how do you retrieve back that? it has to create, it has some sort of structure behind it. And the thing is that it's really hard for traditional databases to be able to retrieve those types of unstructured data, especially the more it gets unstructured, in a way that the thing that is retrieved is still relevant. And we can even think about Google these days and how hard it is to find one thing that we're searching for in Google. And these days we use more and more ChatGPT to find things because it can kind of understand the semantics of what we're really trying to say. So what a vector database does is you turn this unstructured data into vector representations. This is done by an embedding model. And vector representations is basically that data, but represented in numbers. So think of representing a name like a water bottle, but as a number sequence. This is done by a deep neural network that we call embedding model. And things similar to water bottles, for example, I don't know, water cup or something. Yeah,
This
this
one, for
one.
example, it's a different one. I don't know. This is a
Yeah, it's a
metal
different
water bottle,
style.
and so on. Okay. Hmm.
But the embedding model will generate a similar number representation for both of these because of the way that it's trained. And then we have kind of similar vectors. Now, these vectors live somewhere, and that is in the vector database. So basically, when you see things inside a vector database, things that you created the embeddings for, data, unstructured data that now is in embedding form. Inside the vector database, similar things are placed in similar places, and different things are placed apart. So depending on the number of dimensions, this can get quite complex, and depending on the amount of data, it can get really big, but we can talk about that later. But yeah, that's the party level overview.
Okay, perfect. Okay, thank you so much for explaining these very simple terms. I think if you like math and vectors, maybe you have can have even a math representation in your head. Before we keep going, I want to like to ask you if you think that Italians and Brazilians they are similar. They will be similar in a vector database or not?
They would be pretty close, yes. And I think it would be a little bit further apart from like North Americans and maybe, I don't know, um, English people. You can see there.
Fine.
You're already catching it. Yeah, that's exactly it.
Perfect. So this was not planned, and I think this is a nice example and a nice explanation. Perfect, Sabrina. So I would like to ask you something before we dive deep into maybe even Qdrant. I would like to ask you more in details. Let's say that we don't have vector database. We didn't invent vector databases. Like I don't know, we didn't invent electricity. No, the steampunk environment, no, and novels. So without a vector database, how could we have something like similar to what a vector database does? Maybe at application level, how do you think that this could be done, but without a proper vector database? So maybe we should do this, like all this logic should be handled at a different level.
It kind of depends, right? Some of those things you can kind of achieve with traditional machine learning methods. For example, training a small model in a specific data set, and then searching to that, querying that model itself, rather than really uploading it to something like a vector database or performing vector search. You actually train a model to kind of understand that data. But then again, it's quite complex to do, much more complex than really just embedding documents and inserting into a vector database and retrieving, especially depending on the type of use case. Sometimes it might work better, but then you'd have to really have a good understanding and a good amount of data that represents really what you're looking to achieve. Um, Other ways, it can be even like using the context window of large language models, but then you are limited to only a small amount of data that is able to the model is able to understand at a single moment. And then again, it doesn't really get you what you want that easily, because it gets lost on what's really the important thing that you're looking for. So there's a few things that you can use to, kind of dodge the use of a vector database. But these days, if you're really working with large amounts of unstructured data, that is usually the easiest and best way to move forward.
Perfect. Thank you. Thank you for this. Thank you for this answer. And I would like now to get into more the technical details, because soon we'll also make a demo, of course. But before that, I would like to introduce Qdrant connected to the concept of vector databases. I see many people asking like some specific questions about Qdrant. I don't know if you can answer them all. We can have 5 minutes. I would like to, if you have any questions specific to Qdrant and vector databases, drop it now. And because, let's say, vector database is a concept, and Qdrant, as far as I know, is like an implementation of this idea of a vector database that then is basically a technology that can be used, that is used by many applications. I think I saw TripAdvisor, I think by Andre, a couple of days ago. So, Sabrina, please give us a real idea of what Qdrant is and how is using vector databases as a service, basically, also for many other applications. I really love this approach that is like a service that then is used by big applications. Okay?
Absolutely. Yeah, so Qdrant's a vector search engine, and this is usually how we want to call vector databases these days, is basically vector search engines, because what it really specializes in is in retrieving the correct data that you have inserted into it. So after we have transformed our unstructured data into embeddings, there are multiple types of transformations and things that we can do to insert them into our vector database in a way that when we retrieve, it's more accurate to what we're looking for. So we can use, for example, metadata along with our vectors. For example, I can use insert a vector, but I can, along with that vector that represents unstructured data, send, for example, if it's a book, I can send the title of the book. I can send the URL of where I found it. I can embed also the image of the cover of the book. And I can do many things that when I retrieve or when I ask a query to my vector database, it can actually find the actual really more specific thing that I'm looking for and not being so generic. That helps, for example, in RAG applications, my model to not hallucinate, for my model to get really the data that they're looking for. And that is very, very important. So I think there is even a few other questions. Oh, I see Bia in the audience. Hey, Bia. There's a few other questions that comes with it, which is like, what makes Qdrant a good vector database? I think I saw this question somewhere. And it's really, the focus of Qdrant is performance. So, of course, Qdrant's written in Rust. This is why I have Francesco here by my side. And, this comes with a lot of technical decisions also built into Qdrant and how it is thought to be. So Qdrant is very focused on performance. So trying to do everything in a way that you get the most speed, you get the most accuracy, and you also save the most resources. So basically, it's a very good way to do this at scale. If we're talking about billions of vectors, it also works at a high performance. So yeah, that would be the overview.
Perfect. I was about to do a poll, but I'm sure that not everyone here in the chat, they know what a RAG is. So maybe I will make this question. And so feel free to drop any question about specific terms if you didn't understand some of them. So we have Sabrina here, so this is the perfect moment. And then we are more warming up, and then we'll get into the coding part. We'll make an example. Sabrina will propose something. I'll do stuff, and I'm looking forward for that. So we have already a couple of questions, but So, Sabrina, please give us an idea of what RAG is.
Yeah, absolutely. So rag, we're gonna build a rag today. Francesco is going to teach you guys how to do that. So rag is basically when you have, for example, a data within your vector database, and you want to, for example, feed that data to a language model to basically create a sort of memory to your language model on what data you want it to know about. So basically, when we talk to ChatGPT, it kind of knows a lot of things, but it doesn't know really, really specific things. For example, tell me everything that you know about the latest medical articles on Alzheimer's or something. It's gonna have a good idea, but it can go really deep into what you're looking for. Its data set is kind of limited to what it was when it was trained. It can be improved these days via a bunch of methods, but it's still not as good as if you could insert into it the actual data set with that information. So what we usually do is that, hey, ChatGPT, can you pick this file here and tell me about what it is, what's goes on with it, what's happening with it, or ask questions about that file. And basically, a RAG application is kind of um, that at scale. However, instead of giving it to ChatGPT, because it wouldn't be able to understand the entirety of the context that's in, like, for example, a million papers, we wouldn't be able to feed a million papers to ChatGPT. We basically insert those papers into a vector database, and then when the user asks a query, we use that query to retrieve the exact paper that has the most relevant answer to the user response, and then feed that to ChatGPT, only that part, so it can give the best answer. So basically, this is what we're going to build today as well.
Perfect, perfect. Looking forward for that. We have some questions, so let's take a couple more minutes and then we'll jump straight into the demo part. I'm really curious about this one, if you have an answer. Of course, we are developers, we are not even getting started in creating our first vector database, and we are already talking about scaling. I love this. So, introduction and traditional database, I can scale up vertically and horizontally. What about vector databases? Can you explain
Yeah.
how it usually scales?
Basically, I would say in a similar way, you can also scale vertically and horizontally. You can create more nodes. You can, improve replication and have replicas of your vector database across different machines. And it kind of works in a similar way to traditional databases there. We usually recommend you to keep your original database separate from your vector database because you don't want those types of data being, for example, you don't want the vector database to affect your original database. You always want the vector database to be its own entity that can work separately. But I'd say, like, in terms of scalability, you can think of it as just working as in the same direction. I think COVID also asked a very interesting question on how do you guys perform semantic search, right?
I can't find it, but okay. So about semantic search, I think we will do something today about this. I can't see the question, but please go on.
Yeah, so it asks quadrant sort the data. How quadrant sort the data? I mean, if you can, like, say how you guys perform semantic search. So this is interesting because if you go back to when I said, like, similar things are placed together in the vector space, you can think of, okay, but how does quadrant, like, takes this back? How does quadrant actually finds that information in the vector database, especially when I have billions of vectors, right? How does it really knows what to retrieve? I think I'm interpreting this question right, but please let me know, COVID-19, if that's the case. And the way that it does at a large scale, obviously, if you're gonna, like, search every vector one by one, that's gonna take a lot of time. So basically, when I ask a question and it has to retrieve an answer, it also turns my question into a vector, so it can like be kind of placed within the vector database as well. But as when I retrieve a vector, I kind of know like what I'm looking for when I have my vector. So you can think of it as, we can use a metaphor. For example, when we walk into a library, things are not like randomly placed. If the library had like just a pile of books when we got in, if we wanted to find one specific book, we would probably have to go through most books to actually find um, our book. But a library is not really organized that way. A library has like these sort of organizations, sections, and you can organize a section by many things, by shelves. And then when we walk into a vector database, it's kind of similar, the way that things are placed, but it's all organized by an algorithm that we call HNSW, which is hierarchical navigable small worlds. And the way that it does is that it organizes the vector in a way that it really makes the retrieval fast. For example, let's say you're looking for someone in a crowd, and you know that person, you know a few characteristics of that person. You know they are blonde, you know they have a white t-shirt, and you know they have like green eyes. So how Quadrant does it is that, okay, let's remove all people that are not blonde from the picture. So then you reduce your vector space to a much shorter thing that you need to search. And after you've done that, okay, let's now remove everyone that doesn't have a white t-shirt. And then you reduce your vector space even further. And then you go on and like, let's remove everybody that doesn't have green eyes. And then you already have a very small vector space that you're searching through. And it's much, much more easy to find the one that's closer to what you're looking for. So yeah, that would be how it kind of sorts the similarity search.
Yeah, thank you for explaining this in so layman terms. From my experience in using a vector database, usually there is, I think, an extra step of indexing this data. But I mean, I think this takes a while, but I think then it pays the effort, of course, to make at least one or two searches. So is this correct? There is like an indexing phase that, of course, it will be
Yeah.
very useful later.
Exactly. So this indexing phase is literally like putting those vectors into this HNSW index. So basically, we organize the vectors in a way that we can do these types of search. And then we basically make searches much, much, much more faster later on. So maybe if you have like a very large data set, you can spend like an hour indexing, 2 hours, but then when you search, you are able to retrieve things in like half a second, which is really better than, having to search one by one.
Is basically what we want. So that's that we have this phase when we prepare, let's say, the application, and then it will be ready to answer very, very quickly. I want to pick this last question by Arindam. I will give you one last question if you have time, and then we'll jump straight into the demo.
Yeah.
Arindam asks about vector databases in agentic AI applications. Is there like a specific approach for these kind of applications?
Yeah. So when you're building agents, what an agent really is an LLM that can kind of like make decisions of what to do, right? It can make decisions on how to retrieve a specific answer, how to write something better for the user. So you're really creating a decision layer for your LLM. And when we think about vector databases, it acts as a memory for your agent. For example, if you want your agent to have very detailed knowledge of a specific subject, for example, legal data, you can embed a big legal data set into your vector database, and your agent can retrieve from that database when it decides that the content that it needs to retrieve back to the user is within that database. So basically, you're giving your agent a new layer of access to memory and detail and information that it wouldn't have otherwise, which is really valuable.
Perfect.
Oh, Terry.
Thank you. I think he works. He works at Qdrant, right?
Yeah, he's my colleague.
Perfect, Theory. So if you want to see me fail in this live stream, please stay. So you can. I think you can also help a lot in the chat, especially while I'll be busy doing stuff. So if you can, please stay. Sabrina, I'm warmed up. We answered many questions. I think it's finally time to go straight with a real and concrete and in action example. Otherwise, I would have to change the title of this series. I'm joking, of course, but no. But I think in this case it was really necessary because sometimes
Yeah.
we made some episodes on some already well-known technologies. In this case, I think it was really worth it, and thank you also for answering the questions. Really on point.
Absolutely. Let's get into it. Let's stop stalling. Francesco, you're doing some
Perfect.
coding today.
Yes, I didn't know this. I didn't know this, but as I said, I'm absolutely 100% shameless now. So I will do this. And so, Sabrina, I will let you lead. If you want, do you want me to share my screen? Do you want to share your screen? What do you think is the
Yeah,
best
awesome.
way?
So I'm trying to share my screen now with the workflow that we are going to be building. So I'm going to tell
Share it.
everybody. Yeah, you can share it. We're going to tell everybody like what we're building here today. So we're actually using a very nice data set example here, which is Francesco's The Rust Workbook. If you haven't read it yet, I highly recommend it, especially if you're learning Rust. But yeah, the thing that we're doing here is that we're getting the entirety of the Rust Workbook, and we are turning it into chunks to send to our vector database and then create a rag with it. But one thing that we haven't mentioned here is this part of chunking. And what does that mean? Like, can I just embed the entire Rust workbook into like a vector and put it on my vector database? And it's kind of like not how it works. So what we want to do is that if we do like the entire Rust workbook and put it into one single vector, the context that we're going to have is super limited because one single vector can only have so many dimensions, and the Rust workbook has 92 pages, I think, and it's a lot of information. So basically, if we try to put that into one single vector, we're going to lose a lot of stuff. So what we do is that we grab snippets of that book. We call it chunks. We grab like small chunks and feed that to an embedding model and create the embeddings of those specific chunks. And then we basically add that to the vector database. So then we have more rich context into each chunk. And then we feed that to a LLM and get answers based on that chunks that we retrieved. So yeah, that's basically the workflow.
So basically, instead of having, a full cake to eat, we have many small candies, so there's more digestible, right?
Exactly. So that there's more context and it's easier to retrieve, and the database really knows what we're looking for. So it's really about like the more obvious that you make for the vector database about what it is that you want, the better. So in this case, we're trying to make it simple, so it's like digestible.
Perfect. And before we start, I want to mention that Sabrina created this schema, I think, in 2 minutes just before we went live. So this is just kudos to her for creating this very great schema. But I think this will be useful. We are using this Rust workbook, which is I think I created this 6 months ago, which, just to give some context, is a collection, I think, of 25 exercises about Rust. So there is a say exercise and then also the explanation about different topics in Rust. This is an idea that's something that I wanted to do 2 years ago, and usually after a year, one day I wake up and I decided to make this live. Okay, so I have a clear idea of this, and I see also Gemini here. So I think we'll use Gemini under the hood, right? We'll use the Gemini API somewhere,
Yeah, we're
right?
going to use the Gemini API as the generation part of the process. So when we talk about RAG, we're talking about retrieval augmented generation. The retrieval is done by the vector database, here is Qdrant, and the generation is done by Gemini, which is basically the Gemma 3 model that we're going to be using by Google. And basically, what the model is doing is augmenting our response that we retrieve from the vector database to be more human readable, and so that we can really understand what it is that we're looking for. So this is why it's called retrieval augmented generation.
Perfect. Perfect. I really loved this explanation, of course, also of the R, A, and G, what this does mean. Yes, we'll answer the questions about not what we are doing now. So, for example, a question about JavaScript and TypeScript at the end, maybe if we have time. Now, let's focus on this example. So, Sabrina, how would you suggest to keep going? Do we have a project? We do this from scratch, so this will take 4 hours. I will let you decide what we want to do, also depending on your needs. My only constraint is that I have a pizza in 3 hours, so that's my only hard stop. I'm sorry.
3 hours. Okay, can we get Francesco to build a rag in 3 hours? I'm asking the chat now. No, please. Let's continue in your Google Colab. So basically, you can share like a new collab, and we can all like get started. But then I want everybody to also like follow up. And really, I think we can share the link to the full collab that we're going to create here with this full workflow already working to everyone, and kind of walk through how you can make it work. How about that?
Yes, I have just one question before I share the link. If we share this link, will people allow like to change the things, or just they'll create their own version for them?
Let me send you just the reader link just to make sure it's just reader. The last one that I shared with you is just reader.
Okay, so you shared something here.
So you can basically use as you wish.
So the last link you shared is just something if you want to read it on the side, maybe if the screen is too small and so on, right? The last one.
The last one you can actually run it. You can definitely run it.
Okay, so the last one I can share it. I will do it. Okay. I know you are polite, but I mean, okay. COVID. Thank you so much for wanting me to create this from scratch, from zero. But I mean, if this is something that we like, we can even make another version. Let's make an introductory version. By the way, I'm fine. Thank you so much, Colin Jimmick. Let me share my screen. Perfect. And I want to put now this.
We're going to start a 12-hour live stream right now.
I mean, now that I have a standing desk, I can also do this in a very easy way.
Do you remember to use it at all? Like, I think I've used mine like 5 times.
What?
The standing desk.
I did a 10 hours live stream by standing, so it's amazing.
Really?
I think I can be the best testimonial for autonomous. I'm sure, because they sent me this standing desk, so I'm waiting for my compensation about this high promotion for this standing desk. Anyway, okay, so here is a link of something I made a couple of tries. Maybe we can go through the whole process again, so we can just start explaining. So Sabrina shared this with me for real just right before jumping into this live stream, so I didn't have much time to check it. Here we are using Colab. I never used it much, but basically is a cloud environment to test cool things without installing them on your machine. Something like
kind
this.
Of like that. It's a very useful tool that Google created for People to be able to collab on the same file, basically without needing to install all
Mhm,
Python libraries, think about versioning anything. You can just
mhm,
basically add the code, run the cell, and have things work.
mhm.
Obviously, this is basically for testing. You definitely want to have a proper setup if you're doing this in production or anything. But here we're just testing and having fun.
Yes, and just to mention that, for example, Julia, my girlfriend, she used Google Colab with Python many, many times. So she's probably knows Colab better than me. But I see here Python stuff. So I see Sophia and the Python people will be happy now. And I think it's a great language to test these things. Jokes aside, we're not on Twitter now. So I see here we're installing this dependency. This is the first time that I'm actually reading it. So we have this Qdrant client, Docling, I have no idea what is that. Fast Embed and Google Generative AI. So maybe what
Yeah.
is Docling?
So Docling is the one that we're going to use to kind of structure our data a little bit to make it ready for chunking and also chunking. So this is what we're using for that. In Quadrant
Okay,
Client here, obviously connecting to the Quadrant Python client. Fast Embed is a Quadrant uh, created library for
okay,
embedding your data really quickly. And then we have the Google Generative AI, which is the one that we're going to use Gemini, which is our LLM Gemma 3.
perfect. And if sometimes I will say Gemini, I'm sorry because Gemini is a Latin word, and I've been spelling this like that for my whole high school times. So sometimes I say Gemini, but it's not my fault. It's just that just it's just how it should be spelled in Latin, but it's fine. Let's call it
It's just the
Gemini.
correct version,
It's
right?
fine. It's fine. I will change and twist my brain, but in case I spell it once wrongly, just forgive me. Also, there was a famous cartoon like the Sanseiya, and there was Gemini was basically the final villain. Spoiler. So let's see the process, Sabrina. So here we have this part.
Yeah.
What else do we need to add to make this thing work? So we are using this PDF. Okay, so we are
Yeah.
using this product that I have. What are the prerequisites other than just adding this thing?
All right. So definitely, I think we can like go through it as we have to create. Like, we obviously need also to add our PDF of the Rust workbook,
Okay,
and we also need the API key for Gemini. This are
okay,
the things that we need to do outside of the
okay.
code.
I
Yeah.
think I will. I don't want to share, of course, publicly my API key, but I will show them here. Is that okay for you, or I have to do this again from scratch?
No, yeah, you can show it here.
Okay.
So
So,
basically, yeah, you can walk through like the process, but here you're just gonna add the um, Rust workbook to the data folder.
okay. So we have the PDF here. Okay. Perfect. And in this folder called data. And then here, I hope this will not show on screen. Thank you so much for sharing this, Google. We have this Gemini API key that basically will be used to do, let's say, the G, so the generative things, right?
Exactly. So if you go to the left sidebar, you're going to see the folders where you're going to add. Basically, it doesn't have to be the Rust workbook. It can be any PDF that you want. And if you change a little bit, the code can be any type of uh, document that you want at all. And then
Mhm.
on the key icon, you're going to add your API key. It can be the Gemini API key. In this case, we're using Gemini, but you can also use OpenAI. You can use many different providers for that.
Okay, and we have Patrick Lauber. He works at Google now, so in the Google Gemini team. So Patrick, I hope that we're making you happy by using this this
Patrick,
model. Feel
yeah.
free to stay and also promote these things because I think it's an interesting workflow, I would say. So let's keep going. We're using Python and Google Gemini. So you should be absolutely happy. He has a YouTube channel called The Python Engineer. So now he works at Google Gemini. So I think
Wow.
Patrick is a happy person now.
Thanks,
Let's
Patrick. Yeah, I'm actually using Gemini because he commented, "Hey, use Gemini for this project," and I was like, "Yeah, let's do it."
see, sometimes Twitter might be actually useful, which is mind blowing. So it actually might be useful to decide things. Okay.
We also have a question
Okay.
on what's the model that we're using. For this one, we're using Gemma 3. Let me see how many.
I think we had the PI key. I can't read it here.
Gemma 3
Uh,
27B. Yeah.
okay, perfect. Great. Okay, and now you can fight about models in the chat while we keep going with the example. Perfect. Okay. I think
Is it better than
it's
OpenAI SDK? It's it's a matter of opinion of sorts. You can like use both, try it out, see what you think. Maybe Patrick can talk to you more about it. But
Patrick
yeah.
now. I think Patrick is taking a while because he didn't reply that quick because probably he's writing a long answer
Oh
to
yeah,
stay
that's
here because
true.
he's coming full developer advocate mode.
However, the
Perfect.
Gemini API that we're using here is free, so you don't have to add credit cards or anything. So you do
Okay.
need to do some of these things
Very,
for
I
OpenAI.
think this is a killer move for developers and letting them to actually do stuff. So Sabrina, we have these with all the requirements. So I think that
Hmm.
Google Colab works that I can run some of these parts. I think we run this just once, but maybe I want to show the process again. Maybe it would be easier and quicker for you.
Maybe, yeah. I think
In
it's already installed, so you can just go ahead and import the library. So yeah, I
okay.
see that you've already run a few of those cells, but that's
Okay.
okay.
I mean, not just want to maybe run it again. I think it will
You want to
not.
clear the whole thing and run it again? Like you can go to runtime.
We can probably this will take
No, no.
some time. No, this will delete the code.
Yeah.
Yes.
You can go to
It's
runtime on top,
mhm.
and then you
Maybe
can
the
like
run
restart the session.
restart the session. But then
And
we
then we
also need
can
to re-add the data and the Google API key.
probably the data, but I'm not really sure. But yeah,
Hmm.
the API key, no. The API key will be saved.
Restart session. So we are
Yeah,
not
let's try it.
cheating. Okay. Perfect.
Hopefully we can still have like the
Let's
workbook.
see. So we still have this. We still have also the data.
Oh, great. Yeah.
Okay. So now,
Let's just
okay,
run it. Yeah.
here. Perfect. So we can start running these things, and in the meanwhile, okay. So let's start these things, and I think while we are doing this thing, we can explain what is going on. For example, here we have this import. Maybe I can do the run all here. What do you think?
Let's run
Or
it
do you?
one by one so we can like show.
Okay, you want to do the satisfaction of clicking the single one. Okay,
Yeah,
I
yeah.
agree with this one. Here we are importing these libraries. Maybe we can make it just a bit bigger. Importing libraries that
Oh,
we're
have
using.
you installed it already? Everything?
Installed what? Like
You're
this
gonna
one.
need to install. Yeah.
No,
Oh, you,
I
you
already
did. You
clicked
did.
this one.
Oh, that was
Okay.
fast. Yeah.
Yes. Let's keep going. So we have these, and you should have the link here in the chat. Pradumna is here also on Twitch. I think most of the
Yeah.
people are on YouTube today, but it's fine. Document converter. Here we are having this source with the path
Yeah.
of the file. I will be curious about what happens if we have multiple files, but I think it should be a similar structure. Maybe we'll have an array of sources. I have no idea.
Probably. Yeah. I
Okay.
think Docling has a very nice documentation. So maybe it's just like you can create an array.
Okay.
But basically, what we're doing here is that we are kind of structuring our document to be a little more pretty and create better chunks
Mm-hmm.
with docling. Yeah. So if
Nope.
you click there on print document, we can see like what that kind of looks like, what docling like gives back to us
So,
from the Rust
mm,
workbook. Yeah.
so Docling is responsible for the chunks.
Yeah. So he
Okay,
is
got
first
it.
preparing the document and then chunking it.
Okay, here I can even read the chunks. Okay, I clicked something that I don't know if it was intended. Okay, and then we have
You
this
can just click somewhere else too.
chunk and tokenizer that I think is exactly what you are looking for. Perfect.
Exactly.
We take
Just
each
a
element.
second, because you're going a bit too fast because the cells are not yet like processing. Maybe we can go back to the one that's processing right now on top
Sure,
and
for
see. Oh,
sure.
it's still importing. Okay.
Mm-hmm.
That
Let's
part
see.
of like converting is it probably is the one that takes the most time, I think.
Okay.
Because it's a large PDF, but basically everything else is it's much faster. Actually, the embedding process is usually the one that, it takes the most time rather than
Mm-hmm.
retrieval. Pradumna, hi,
See
long
Pradumna
time.
here. Yes. We also have COVID complimenting Pradumna in this live stream. I love when this happens. Like, people like meeting each other and supporting each other, and they support each other on different events. I love this. Okay, perfect. So this probably will take a while. Then we have this print document. Really here is explaining
Yeah,
256 token limit. Perfect. Here. And then let's take each element from the list and we extract the text attribute. Because of course, this chunks is not just for text, right? Or it can just for text.
we're basically extracting the text, but here we're using the hybrid chunker, which is
Okay.
basically one way that's usually the most common that people chunk is that, okay, let's just chunk 256 tokens. This is the max amount of tokens that this model that we're using, all mini LM L6 V2, is able to process within their embedding. So basically, what they do is like, let's just chop this into like many parts of 256. What happens is that a lot of the context is sometimes cut off, right? You can stop at the middle of a word, of a sentence, and just things that doesn't make sense for that embedding. And then the embedding can seem a little bit off. What we're doing here with hybrid chunker, if you go a little bit up, is that we are actually using
Yes.
an embedding, the chunk tokenizer, to embed the chunks so we can kind of see them in a way that is semantically understandable. So instead
Mm.
of just randomly selecting like where to stop, it stops at a point that has a complete idea or thought that has the maximum of 256 tokens, which is the maximum that our model is able to process. Um, so yeah,
Okay, great. This is very interesting. It's like trying, I don't know, to, let's say, in quotes, like ending the sentence that makes sense, and then probably start creating another token, something like that.
exactly.
I like it. I would be very curious to know exactly more in details how this does work, but that's probably for another time. Text chunks here
Exactly.
and here. Then we are
So here we're
pulling
extracting the text and then seeing the length of each chunk.
it.
How many chunks did we got from the Rust workbook? So here we got like 235 chunks.
Mm,
And you can see it's still processing, actually, the pre-processing the document. We still have um, that line is executing like for 3 minutes now. It's probably gonna do that for 5 minutes or so with the regular capacity for Google Colab. So it's a little bit slow. But if you use smaller PDFs, that's gonna be much faster. This
and
is just
yeah,
because
and
we're using
here,
a big one.
and I think we are here. We are also doing this in Google Colab, but maybe locally is a bit different, and I don't know. Maybe it's the same, but
More power, then it's always better.
mhm. I love it. Okay, and here we have this print processing a document into smaller manageable parts called chunks, ensures that chunks not exceed.
Hmm.
Let's see. So we set a max token parameter. Otherwise, so basically, if it reaches 256, it's gonna create the chunk anyway, right?
It stops at basically before, in a
Usually
way
before.
that the full thought makes sense. So basically, if the full thought, takes more than 256 tokens to complete, it tries to, create a smaller
Mm,
thought within that limit. It's usually pretty good.
got it. Got it. Perfect. And then we also.
And here we're using a different tokenizer for extracting those chunks than we're
Mhm.
using for the actual embedding of those chunks. We need to understand those are separate things. And even like I use different models. So you can see below when we're creating the embedding model, we're using the BGE small and V1.5, which is different than the one that we're using to tokenize our chunks, which is the AI mini LLM. So also good to keep in mind.
Perfect. Perfect. And then we also have this print for all these text chunks. So I think we can even read them here, maybe later. I don't know, maybe some parts.
Yeah, it's just taking a little bit of time.
Okay.
Maybe we can answer some questions while we are
Yes, I see
waiting.
yes, I see mostly people fighting for the dev.to and medium logo, but meanwhile we could also have this, but it's fine, it's fine. Open SDK is great, but we have also this, use Gemini. I would like to know your experience, especially if you had any experience with vector databases or if you used Qdrant. I would like you to drop your experiences so far. To me, this looks really great. You have maybe probably if I create another video, I would prefer as a as a good developer like to redo this locally, maybe even installing the dependencies. But I think for this first live event, this was great. And I think at some point we'd also have a link maybe to the code. If you don't have it now, you will have it at some point. Okay, perfect. And then can we keep going, or maybe we can have like a 1 minute
Yeah,
break?
maybe let's just like
This is file based, right? I don't know I don't know what do you mean, Senapati, but I think you are asking like about the data we are using or the server we are using to process the data. What's your
actually,
question?
yeah, that's not very clear. However, I think I know what he meant is like we're actually using the vector database in memory because Quadrant can also be used in memory. It can be used via Docker. It can be used Kubernetes. It can also have an awesome free tier on Quadrant Cloud that you can like insert almost like 5 million vectors, which is really good. So this one we're actually just doing it all in memory. We're not even like creating a server for it or anything.
Yes, I just want to make a quick shout out to the Qdrant Docker image on Docker Hub. So if you like Docker, you can check it out here and have fun for sure. I will do this for sure. So this is a great. I think when I see that a technology is like full, like it's on Docker Hub, it has all the support. It really gets many Francesco points for what they're worth. It happens sometimes that. I heard about the nice new cutting edge technology, and they don't have a Docker image. In that case, I'm not sure if they are ready to scale properly. I see Qdrant, they are doing cool stuff. 10 millions of Docker images downloaded. Perfect. Great. Really love this. I
All
didn't know
right.
this. Okay.
So yeah, the
Okay.
document stop processing.
Perfect timing. So we are.
Before you start embedding, yeah, let's go up and see what happens.
Yes.
What happened after the processing? Oh yeah, there we go. Yeah,
This
it's
one.
this. Yeah, so the processing is done, and then we go and print document, which is basically what Docling is giving back to us from our file, and we see there that later we can turn that into the chunks. If you go to like, it gives us what we need to chunk it, and then we use the tokenizer to create the chunks.
And then we
Like
should
that.
have also this print. No, what is this here? No, this is it. This is the number of. This is the number of chunks.
Yes.
Okay, which is
This is
starting
how many
with,
chunks we created.
so it's 235 chunks made by
Exactly.
about 256 tokens, a bit less.
Yeah, with the length of kind of 256. Yes.
Okay, makes sense. The fact that it's close to 256 is has nothing to do with that. It could
It's
have been
just a
even
coincidence.
300. It's a case just to make things more confusing. Okay, perfect. I know, Pradumna, that you are craving for Docker stuff. He's also Docker captain now, so I'm sure that you will be more interested now. And I think this is a great sign of a healthy technology, 100%. Okay, let's click this embedding model. Okay.
Here we are defining the model that we want to create our embeddings or our vectors, and then we are embedding our text chunks.
Mm-hmm.
All 235 of them we
Embedding
are
the
creating.
235 chunks, and then we can print these embeddings. And then I think here we are starting, let's say, to use the chunks, right? We
Yeah,
initialize this Qdrant client, we have a collection name, and I think this is the first time that I read them, but it's very readable. Also, kudos to Python for being very readable as a programming language. So,
it's
client,
basically English, right?
collection name. Yes, basically, yes. Embedding dim, and we have embedding dim.
We're getting
We have,
actually the embedding dimensions.
okay.
So
Mm-hmm.
yeah, we're getting there. We're getting there.
Mm-hmm.
So what we need when we create a collection in Quadrant is that we need a collection name and we need a few configurations for the vector. For example, the size, which is how many dimensions there is in my embedding. So this is why we're getting the length of one embedding and storing it in embedding dim. So, and in this case is going to be 256. I believe that's correct. It's the one for all
But
many. I can be wrong though. If I'm wrong,
yeah.
like, drop the
No,
correct one here.
okay. No, but I don't know. Maybe I don't know because I'm also this is the first time that I read it. But is this embeddings is like a list of all of them? So okay, yes, embeddings is a list. Okay, embeddings is a list of this embedding model embedded text chunk. So this
Yeah.
should be the length of the first of the list, of the first token of the list.
So all vectors are the same length, and actually
Uh,
this model that we're using generates uh, 384 dimensional vectors. So basically, we're gonna have 235 vectors that have this
got it.
length.
Okay, no, because I was confusing the length of the tokens with this embedding model dot
Yeah,
embed. So the embedding model dot embed is always the same size. Also because otherwise it would be
yeah.
hard to, I think, to work with vectors of
Yes,
like different sizes. I mean, it's probably this is math. If you have
exactly.
different dimensions, you can't sum two vectors, right?
Yeah,
So,
but that's actually interesting because we're talking about kind of like the context window for the embedding to be able to get context within it, which is a different context window, not context window, but a different number than the size of the dimensions that that embedding vector produces afterwards, right? So yeah, we're
mhm,
starting the Quadrant client in memory, so we're using basically our local RAM to do this.
here.
So you guys can see how light this is. It's basically instantly that we can do this. So yeah, after we
Perfect.
create the collection, we're getting like
Mm,
the embedding dimension. In this case, is maybe you can do like you can print the length of the embedding 0 to show how many dimensions it is.
how can I do that? I can add here a line.
You can add like code. You can go to plus code on the top.
Um,
Yeah.
okay, but if I do
Yeah,
this,
you
it
can
will
you
be
can just click
here.
that. It's gonna create a new cell. Then you can do print.
Okay, and then this embedding
Length.
dim.
Yeah, you can do embedding them. Yeah.
Okay. So I wrote some code for this application. So this will count.
Officially. Okay. So you can
Nice.
see, yeah,
Perfect.
this is the dimension of the vectors.
Mm-hmm. Okay, now you can see that I actually write Python code. Points.
Python
What else?
developer.
Absolutely. Okay. Then we have, let's see. It's funny because I
Okay.
never read this,
Mhm.
but it's actually very readable. Like I can actually understand them.
Maybe you can tell us what you think it is.
Okay. I'm sweating. Okay. Okay. So we have these points. Let's say modus dot point struct. It has an ID, a vector, and the payload with the all the text chunks in this new object called text, and that's the value of the text. And then for I and vector in this embedding enumerate. So basically we have this enumerate embeddings. So here we have the number of the embeddings, I think, with a 4. Here is basically creating a structure. This is a structure of points,
Yeah. Yeah,
right? With these
exactly.
values.
So we're actually writing those embeddings in a way that Quadrant likes to receive them. And Quadrant represents each of those as a point. So a point in Quadrant is an entity made up by three things,
Okay.
mostly, which is the ID, the
Mm-hmm.
vector, and the payload. So the ID is the unique identifier. The vector is the actual embedding, and the payload is any metadata that you want to go with it. In
Yeah,
this
it's
case, we're just creating a loop to insert like an ID
mm-hmm.
for each vector, and we're using like the actual embedding for the vector, and then we are sending as a payload the actual text in the chunk. So the point can carry both the vector for the vector similarity and the actual text that's in there to send that to the language model.
Perfect. Perfect. I want to just give 1 second
People
because
are asking for you to switch to Python, by the way.
the thing is that I never switched. I mean, I have Python videos on my channel. By the way, I'm giving away 5 memberships on my YouTube channel because we have time until the end of May. So we are lucky that we had Sabrina here, so we can have, I think, 5, even 10 free memberships. Yes, I mean, I'm here. We are doing Python stuff. I'm actually creating a Twitch bot in Python. Now people will say, I'm blowing, but yes, I also write Python code. Okay, perfect.
Yeah.
If you think that I have to switch,
Mm.
then probably you just follow me on Twitter. This is a clear sign when I read this comment, which is a great indicator for me, so I can understand where you follow me. Okay, print len points 0 dot vector, but this is len of the vector. Okay, but I already saw this number. This
Yeah.
number is the same number. I can't remember a name of a person, but I can remember a number. This is a superpower I have, Sabrina. So if I
It's
read a number,
it's
can remember it, but I can't remember a name of a person.
I
So
mean it's much easier, right? It's
for
below,
my
it's below.
mind, is it is. Sometimes to remember a phrase, I put numbers in the phrase to remember it.
Mm.
That's my brain how it works.
Maybe you are a vector database.
I don't know. No, it's not a joke. Like when I had to study some low exams, people were surprised that I could remember these things because usually I can't remember as two lines. But if there is a number, then I remember
Wow.
the whole structure. I don't know what's happening in my brain, but okay.
M-
Uh,
Maybe you are built like vector search engines. Truly, I'm not even
no idea.
kidding.
I have no idea why, but this works very well.
But but
Okay,
yeah, just before we go, this is the number of the dimensions of our embedding. So
that
this is
we
basically doing
printed
the same thing. Yeah.
before. So okay.
Okay, so this one is uploading the points. And here it's very simple.
Uploading.
All you need to do is put the collection name. And also the points that we just structured.
And the collection main, we defined this here, Rust
Yeah.
dash book, and then we have all the points. And this is a method of the client, the Qdrant client we
Yeah.
initialized at the beginning. Amazing. I mean, it's very understandable, and this is my first time reading this, so great. Okay, we have a query text. I hope this will be gotten right. Let's see. Let's see. Otherwise, we'll just interrupt the live stream, of course. Query vector. We have a list of all these.
Basically,
Oh,
what we're doing here in the query vector is that we're also turning our query into a vector in embedding using the same model that we use to embed the data into our vector database. And here we're using list 0 because we just want like the first answer that we're going to get from this specific method. But basically what we're going to retrieve from this query vector is the actual vector that represents this query, who is the author of this book, so we can use that to search to similar vectors within our vector database.
okay, so here we are defining the query, but we didn't use the query yet. Or yes, query vector. Where can we see here? So here we should see the result,
Yeah,
right? So we have this
exactly.
search result, client query points. This is the method of the client with the
Yes.
collection name, because we can have different collections in the same because now we have a single collection, right? But we might have multiple
Um,
collections. No,
Not really. We can only
no.
query one collection. This limit is
Okay.
the amount of closest vectors that we want to
Mm,
find. So when
okay.
we are, searching through, okay, I want the closest vector, we're actually telling, okay, I want the 3 closest vectors to
Mm.
this query vector.
Okay.
Then
And just in layman terms, how much would you consider it like a 3, like very close, or like not that close?
I'd say it depends much of your data set. If you have a lots of vectors, then it changes. You can use maybe less, but if you have like not a lot of vectors, it's good to pick a bit more because you might also not have a lot of context. So it depends on your data set and really how much resources you want to spend on this, because it takes resources to compute each one of those queries. Obviously this one that we're doing is super simple, it's just very short, it's very small, but when you're doing this at a billion scale, you want to be thoughtful, especially when you're querying the database I don't know, thousands of times a day and doing processing with those retrieved answers. So basically we're actually sending all of these to our LLM, which is the part that actually takes up the most resources.
Perfect. And I think we already have here a payload of this.
Yes. So when we get the result back, we get it all of the 3 things that we get on the point. We get the ID, we get the
Mhm.
vector, we get the score, which is how similar it is to our query vector,
Mhm.
and we
How
also get the
is
payload.
it 0.73? Nice.
Yeah. And then the
Mhm.
payload is basically the text of what that vector represents. And that is the context that we can share with our LLM to answer the question.
Okay. Perfect. Okay, here I see. Okay, I don't know if I should have had my name here somewhere. The sanction. Maybe this is a disclaimer that it's found. And why there are multiple search results?
If there are multiple, like, for example, we can have like it get only one result, right? But that one result that retrieves might not have the answer that we're looking for. So this is why we get like maybe 3 or
Mhm.
4 to make sure that the answer is there, and then let the LLM deal with like really finding what we want from the query within
Mhm.
those results. Yeah.
Okay. I don't think that, like, I don't know if in the book I introduced myself in the beginning. I can't remember now, but it got, for example, this
Yeah,
email. So, and I like this that like it's like it made some researches on the full PDF. And
yeah.
okay, perfect. I'm happy
And
with
after
everything.
that, yeah, after that, we're getting that payload. So we're excluding everything else. We only want the payloads, so we can give that to our LLM.
Okay, perfect. I like it. And
Sorry,
now
can you
here,
give me one sec? I
sorry.
need to. Can you give me one sec?
Sure, for sure.
I'll be right back. One
Yeah,
minute,
yeah.
guys.
No, sure, no problem. I hope you're enjoying this conversation for now. Maybe I can be a bit bigger. Feel free to drop your questions. And I think this is also the first time that I read this code. And to be honest, it's very readable. I hope you are enjoying this as I am enjoying it. Um, interesting cause when I build the chatbot, provide the each context in code. Okay. Great, great. Thank you so much for supporting it. Of course, let's cheer for Sabrina. Let's make some noise because she's dedicating a lot of time here. We already crossed 1 hour. So, of course, be sure to congratulate her, make some noise, and so on. We're back.
Sorry, I had to
Okay,
answer the door.
perfect. Okay, so here we have the search result, and then here we are defining this context with a sort of join. So we are joining the payloads, we are joining the
Yeah.
results,
You're
right?
basically putting it all in one single block so we can send it to
Uh,
our LLM.
okay, okay. Of course, this took a while, but finally we have what Sabrina deserves. So a proper compliment, of course, about the streaming setup. I think also
Thanks, Patrick.
the red headphones. I think they are playing a big role in this. I really like it. This might become a whole brand.
This is my
For
trademark. Yeah.
yes. Okay. So we have this context, and now let's print the context.
Yeah. There
Okay,
you
and
go.
here, okay. So I think it used the disclaimer. I think that I
Yeah.
added. I think, but
Maybe
I
you
think this
didn't
was.
introduce yourself, like, I'm
I
Francesco.
can't remember. No, but I can't remember, to be
Yeah.
honest. Maybe I did this at the end. I can't remember, but because probably I had a part when I made this disclaimer. Also, this was my first paid product, so I followed all the possible rules by law and
Yeah.
stuff. This took me, of course, way more time than creating the book itself. I think it
Yeah.
got the author keyword in some ways, so it got
Yeah.
some good information. But I think it's sort of good, and he also found my email, so it's
Yeah.
nice. I'm happy. I should check the PDF, but it's I think it's
Yes.
still it's a good one. Mhm.
And then let's
Um,
see. Let's see if the LLM can process this and make sense of it.
mhm. Okay, and then we have now that I've done the retrieval, let's do the generation. Okay, let's
Exactly.
click this. I hope the Gemini API key they work. And then for M in this Gen AI list models, if
Yeah.
generate
Here.
content. Hmm,
Yeah. Basically, here we're seeing like all the models that we can pick from this Gemini API key, um, and basically choose from there. So
mhm.
yeah, it's just a list of models.
Okay. Hmm,
We're using Gemini 3 27B.
this one. Okay.
Yeah.
Perfect. And now we are defining the model.
Exactly.
Okay. Okay, this is just a print. Here we're doing nothing. We're just printing the models. Just because we know the developers, they are curious about the models, but then we are basically just doing this, right?
Yes.
Okay, I got it. This was just to delight the developer audience and read some of the models. Okay, got it. So we define this model.
Yeah.
Prompt. You're a helpful assistant. Use the following context to answer the user question, and if you can't find the answer in the context, say you don't know. I love this.
Yeah, so
Context,
basically, we're giving the
question.
context, we're giving the query, and I just checked the workbook. You actually say, I'm Francesco. You can find me at, francescosilo.com. However, it didn't have like author in it or anything. This is why it didn't
Okay.
match in the similarity space. So now we can see really how this works, because even though he says, I'm Francesco, that doesn't really gets close to the same embedding space that the question is, which is who is the author, unless you are also cited as the author somewhere in the file. So the author is Francesco, so it can connect those two together. You see how it works?
Mm-hmm.
Yeah. But then it's basically those things can be improved with other methods like hybrid search, where you can actually add keywords that make our life much easier when we're trying to retrieve very specific things like this. And
Mm-hmm.
maybe for another video, we can talk about that.
We will see. Okay. Perfect. Okay, so we have this prompt, and then we will use the prompt giving a specific context and a specific query text. Okay,
Mm-hmm.
perfect. And then we have this response, model generate content prompt, and then we print the response text. I mean, it got it
Yeah,
99% correct. Just missed a space,
it missed the
but it's
space.
fine. But it's fine.
You know
It's
what
fine.
we could try? We could try increasing the amount of answers retrieved to like 10
Hmm.
and see what happens.
So you see, okay. So do you mean that I can write 10 here?
Yeah.
Okay. And now run
Yeah.
all of them or just this one?
Yeah, you can run the query point, you can run context again. Let's get more context and see what it
Okay.
got. Let's try to do it again and see if it gets right.
But I mean, it almost got me. Okay.
Yeah,
Here and here.
there you go.
Perfect.
Sometimes you just need a little bit more
Even with
similar
capital
things.
F and capital C. Perfect.
Exactly. But there is a trade-off. If you get more things from the vector database, you're feeding your LLM with more context, and that is a bit more expensive if you're using paid models. So there is a balance to do. Obviously, we're doing here at a small scale, but be mindful when you're doing this at a production setting.
Okay, perfect. Let's keep going. Now we have this Python function, rug respond with Gemini, embed the query, retrieve relevant context, format prompt for Gemini. A helpful assistant.
Yeah, here just defining the function that we're doing. And we have a question here from Brian, which is vector search isn't great for this question because it requires a bit of reasoning. It's not that it requires a bit of reasoning. If you use, for example, hybrid search, you can get really specific with it because of keyword match, and then we can like talk about this in another way. However, for most questions that we perform and we're using, for example, RAG, it does need a bit of reasoning to make it as beautiful for us to understand as humans, obviously. So basically, this is the whole point of RAG, right? Just getting us exactly what we need from the vector database in a way that's beautiful and that we don't have to read ourselves and interpret ourselves. So yeah, in that sense, yes, we do need a bit of reasoning. This is why we're using language models for it.
Perfect. Okay, step 3 is context below, context and query text again, then generate with Gemini, response model generate content, and then we return it with this function. And then we have this
Yeah.
response. You call in the method, tell me about ownership in Rust. And I think this was a prepared
Yeah.
question. Perfect. And then we can print the response. Maybe you can run it again, or maybe you can try something
Yeah, you can run
different.
it again, see if it changes now that we are getting more context.
Okay. Oh, no, wait.
Oh, you
I
got.
didn't run this. I'm sorry.
Oh,
Wait.
Oh yeah,
Oh,
there you go.
calm, calm. Let's calm
Calma,
down.
calma.
We are calm. Perfect.
It
I think
takes
this
a
is,
bit more time. Yeah.
no, but I mean, I think this is a great way also to demonstrate stuff.
Yes.
It's
Step
nice.
by step, right?
I
You're
like it.
seeing the
I
power of
think I will
collab.
start using Google Colab more. Okay.
Ciao,
And
COVID.
we have here lesson. We have here an answer. Language. I like how I really love this answer because it's not like the generic answer that
Yeah.
you get from Google Gemini. You can ask like, "What is ownership?" and it probably write a lot of
Yeah.
stuff, and that's it. Here is answering about this thing related to this workbook. So here, for
Yeah.
example, just to give context, these are basically 25 Rust exercises that you can do, and here there is an exercise, and it's talking about the context of this book. So this is really, really interesting. We have it's even mentioning specific sections, so it's very, very useful. This one.
Yeah, because it doesn't like make up things. If you go back to the prompt, I
Mm.
specifically tell him like if you don't find in the book, just say you don't know.
Well, we
In the
can
prompt,
find
yeah,
it
the prompt is
where
if you go, yeah,
here.
there you go. If you go like, yeah, just say you don't know. I think it's not in the function though, but it's there in this one. It's something
Eh,
important for so that the
uh,
language model does not
prompt.
hallucinate.
Here's the prompt response
Yeah, we create the prompt
here.
again, like yeah, below. So yeah.
Mm-hmm. Okay. Perfect. And we are at the end of this. I think we have. This is another one. So basically,
Yeah,
here,
you
if
can
we want,
basically
we can write more, but I like it.
you can I can ask any question that you want and we can see like how you would reply
I
to
will
it.
I will not do it, but if anyone is here and they are curious about something, I will write it here below. So I will give you a couple of minutes if you have a specific question like this one, and we'll write it. We'll also give credit for a question. So if you are following this whole live stream, this is probably your
Yeah.
moment to ask some stuff.
Maybe we can do
Um,
something that's not in there. Like how can I learn to skateboard and see if it replies. Oh, yeah, but
okay.
first try to put in the function that if the answer is not in the book, don't
How
respond
to do
or say you
a
don't know.
perfect carbonara?
Oh, that is a tough one.
Let's see.
However,
Don't trust Google.
change
Sorry.
don't trust yeah don't this is a very hard one. Very few people on the planet know the answer for this one, but before you hit play or start, change the function that we defined to include in the prompt um, that don't reply, say you don't know if the answer is not the
Because we
answer.
made an example here
Yeah,
with the prompt.
because we defined the prompt again in the function that
In
we're
the
using.
prompt again, okay, it's fine. Maybe I can copy this one.
Yeah, you can copy
I
it
can change. Okay.
and then yeah you can change the
I
starting from
think
like
it's this
your
one
yeah starting from
here.
you are a helpful assistant. Yeah.
I think I copied the whole thing, but wait, because here we have this F. Where does it end? This
You
one.
can just like after they use the context below to answer the user's question, you can say like if you don't have after the
Okay. Yes, I got it.
yeah, you can just add afterwards and it won't affect the code.
Okay. Because here we are. Okay. So
Oh no, after the question dot.
because we have that like this.
Yeah, I think it works like that too.
Let's see. Now I can run this one, and let's see.
Yeah.
Let's try. Let's see.
Oh yeah, say.
Perfect. This is exactly the answer I wanted.
Oh yeah. Oh, this is
Cooking
a
or
good
recipes.
question.
So it also got that carbonara is a cooking recipe. Got it.
Yeah, because yeah, the language model knows that, right?
And I think that this is very important. I was thinking about. I think I was like I don't know. I read something about like these models. I don't know, hallucinating, for example, for laws or like I don't know, mentioning
Yeah.
some some causes, some low suite, and it's basically hallucinating, like mentioning low suites that never existed. So, and I think in that case, we can restrict the search exactly on this, because sometimes we don't want the
Mm-hmm.
model is trying to be too smart, and sometimes we don't like it because I don't know. Let's say that we want. Let's say that we have an article, and we
Exactly.
need
Yeah.
to summarize this article, but it has to be the summarization of the article. So we don't want to add
Anything
other
else outside?
information. Okay,
It
so
can be
this
even
can
like a
be,
little bit biased if you get too much of the
yeah, or it
model's
might
own
get
opinion.
the usual information. Maybe we don't want it on purpose because maybe we want to restrict this
Exactly. Yes.
just on these. For example, it happened. I don't know. Let's say, for example, that you need to create a Rust tutorial. You don't want to introduce newer concepts before talking about them. So you want to restrict the information on just these, because otherwise you
Yeah.
are, mentioning something that maybe is at the end of the course, in the first lesson, so just because the model knows
Yes.
stuff. So I really like these. I also like that they didn't provide like even wrong or misinformation that I will probably fight with a video calling them out. So Sabrina,
Yeah,
thank
that's
you.
that's oh
And
yeah.
yeah, no, please go.
That's 100% the point of RAG, is trying to ground the knowledge of the language model into real information and make it more trustable. And just before we go, last question from Kay Senapati, which is, how do we differentiate documents in vector DBs and from different users? And there is a very especially if you're working with like multiple users that you need to keep separate data from, you can use something called multi-tenancy. And maybe I can share the link here with Francesco, and he can like share on the YouTube. I'm not in the
Okay.
YouTube chat right now, but
Mhm.
basically you're going to use payloads to define the user, and then everything related to that user you're going to define to a specific for this payload, and then you can differentiate and include like security measures and a bunch of stuff with multi-tenancy, um, and also use payloads to differentiate documents across anything. Like for example, if you're working with multiple books, you can use payloads to store the titles of each book to a specific vector and so on.
Okay, great. Perfect. Thank you, Sabrina. So we did a bit overrun here, but it's fine because we went really on the step-by-step procedure, and I learned a lot. Of course, also in the technical details of how this can be implemented, also with something that I'm familiar with. So maybe this code will probably be available somewhere. So we'll also make a um, GitHub
Yeah,
repository. I don't
yes.
know. We will share some links. No worries. But I would like to really tell you, say you thank you for this cool demo. This was not prepared at all, but I still managed to understand the stuff. Very readable code. Sabine, I would like to leave you just a couple of minutes if you want to make some final message, and especially to say maybe where Qdrant is now, let's say, positioned in the market right now with all this AI crazy
Of
stuff
course.
going on. I'm really curious about this. And that's it. And then I think we just need to start using Qdrant more. I made a full stack Rust application using Rust on the front end and back end, but I didn't. I feel like I missed an opportunity to use like a Rust-based database. I will fix this bug at some point, but for sure I will mention this also in my some upcoming talks and so on. So we just, I think it's time to give it like a real try to Qdrant. Sabrina, stage is
That's a
yours.
pleasure. Thank you so much for having me. Honestly, it's just I've been waiting so long so I can get an excuse to make you try vector databases, see how it works really, and get you to start using them. It's been really amazing. The audience, thanks for sticking with us till the end. It's been a pleasure. And yeah, Quadrant. I'm not sure like how we're positioned in the AI market, like you mentioned, but hey, we are the best vector database if you're looking for one. We can like discuss about that. But it's just really happy to be here and be able to talk about vector search and geek out on RAG. And if you guys want to see more content like this, let us know.